Hey, hello everyone. My name is Dan Painter. I am the product training and development manager at Flint Walling, and I will be hosting today's broadcast titled Basic Water System Fundamentals. So over the next hour, maybe not quite that long, we're going to go just through in a very basic way. We're going to talk about how a variety of well pumps are installed, how a pressure tank interacts, and some of the accessories that you see on the screen, how those are used and the importance behind them. If you get a chance, go back to the website. I think I'm going to be doing a live web conference between now and the end of March. I think I'm doing at least 2 weeks. So if you get a chance, go through and look at the topics that are coming up in future web conferences. Anyway, with that, let's get started. Move my slide here. So again, we're going to discuss submersible pumps, some jet pumps, pressure tanks, and then these accessories that you see. I got to get my laser pointer up here. These accessories that you see at the bottom of the screen, we'll be discussing those. And again, this course is really designed, and in fact, when we hire someone new at Flint Walling, a lot of times they'll run through this very basic fundamental course. So when we look at our pumps and the pumps that we're talking about, there can be any number of sources for the water that these pumps can pump water from. So obviously drilled wells would be a source. City water supplies or municipal water systems, they can also be a source water for our pumps, along with below ground cisterns or buried tanks. Sometimes those applications exist, and the opposite of that, above ground storage tanks. Sometimes these are many thousands of gallons each. And then, of course, a lot of our irrigation pumps, we can pull water from any number of surface water supplies, such as lakes, rivers, and streams. That said, the water that our pumps are going to be designed to pump can come from one of any of these sources. Today, however, we're going to be talking more specifically on drilled wells. If you look at the illustration up on your screen, what I've got here is that in order to get to water, groundwater, we've got to drill a well down to where these underground aquifers exist. Some people call them underground reservoirs or streams, but they vary from one geographic part of the country to the next. And a good seasoned well driller, based on where he's been conducting his business, he knows the various layers of earth. Some of them I have listed up here on your screen, the various layers of earth that he's going to need to go through. Oftentimes a well driller will have a good notion as to how deep he's going to have to go, how far down he's going to have to go to reach these aquifers. And oftentimes they know what kind of a production they're going to get, how much water they're going to get. They can also determine what kind of quality that water is going to be. So anyway, like I said, a good seasoned driller in a geographic area is pretty much the beacon of expertise when it comes to drilling wells and going through these various layers of earth. I want to take you back just a little bit. When I started cutting my teeth in this industry, if you wanted to get water to a house back in, this is going back a few years, you'd go out and dig a hole in the ground. These were referred to as well pits, very, very common in the northern part of the country. Now, I don't know how much these would exist down south, but certainly up here in the northern part where we get freezing conditions consistently, somebody would go out and they would dig a hole. Literally, it was a hole dug down in the well. No rhyme or reason to the construction. Sometimes they were dirt walls. Sometimes they would brick the walls. But nonetheless, they would put a hole in the ground because if you're going to bring water into the house, you got to have a water source out here somewhere. And so what they would do in that well pit in the early days, they would run down what is either referred to as a drive point or a well point. This is approximately 1.25 inch piece of steel pipe. It's got a perforated screen on it, I don't know, maybe 3-4 feet long, and a cast iron tapered tip to it. And they literally drive that well point down into an underground water supply. I know in the state of Florida, these are still very common. Again, you've got very loamy, sandy soils down there. The water table's not very deep, and so oftentimes these well points or drive points are still used to this day to access water. But once they get the drive point into the water, again, there's this mesh screen on the side of it. The water would come in and it would fill that pipe up, and a lot of times they would put a coupling on here with another stick of galvanized, so on and so forth. But the water would, just like putting water in putting straw in a glass full of water, when this pipe went down into this aquifer, it would come up and it would reach a certain level that we refer to as the static water level. So that's wherever that water level would come up to inside that pipe. That's referred to as a static water level. We're going to circle back on this here in a little bit, but the static water level, that is. Anyway, moving on, eventually, I mean, they would actually drill a well in the bottom of this well pit. They would set a rig up over the top of it and drill down, and then they would put a piece of casing in that bored hole. Now, that casing back in the day when I first got started was a lot of steel casing. Today, depending on where you're at geographically, steel casing might be used, or they may use a PVC type of casing, well casing. But nonetheless, this casing has a screen, or they will put a screen on the bottom of it, just like that well point in the previous slide had a screen for the water to come through. There'll be some type of a screen or a mesh screen on the bottom of that casing, and again, they'll drop that on down into where they can access the water in that underground aquifer down here. So again, that water is going to come up, it's going to seek its level, and as we referred to a little earlier, that's commonly referred to as the static water level. So if anybody ever asks, what is the static water level, let's give a description on that. I got to get my little dashboard out of the way so I can read that. Static water level refers to the level of water in a well under normal, undisturbed, no pumping conditions. There you go. That's what static water level is. You don't want to have the pump having just cycled a few times. You want it under no pumping conditions. Static water level is best determined when the well has not been pumped for several hours. But it is important in the pump industry that we understand static water level and where that's at, because so many times that's going to be a dictator as to the type of pump that we may want to install on this system. They also have to, let me see if I can move the slide along. They have to fill this void between the hole and the casing. That has to be filled. A lot of times they'll grout that. But basically the objective here is you want a sealant to fill, again, that void in that hole so that it's sealed around that casing. And the purpose for that is to eliminate the possibility of any surface water that could possibly get down along the side of that casing and actually contaminate the below ground aquifer. So it's very important that these wells that have casing is sealed, again, to prevent the encroachment of surface water. That's static water level. Like I said, it's important to understand the depth to where that static water level is at. In the industry, we've got a couple of standards. If the static water level, say from the pump down to the water level itself, so if you had a pump sitting right up here near the top of this casing, from that pump down to this water level, if it's less than 25 feet, that will be referred to, and it's an industry-wide standard, referred to as a shallow well. And the reason it's also important to understand this water level is because if it is, in fact, less than 25 feet, we can use a shallow well jet pump. There are two types of jet pumps that are readily available in the marketplace. One is referred to as a shallow well jet pump, and if the water level, it's also referred to as a single pipe system. You're going to see this in the next illustration, I believe. But a shallow well jet pump can be defined as a pump that is going to be expected to pull water from a depth of less than 25 feet. And it's also referred to as a single pipe system. If, in fact, the water level is further than that, the static water levels more than 25 feet. That is going to be referred to as a deep well. And again, it's important to understand that because deep well jet pumps are also available to be able to pull water from a depth deeper than 25 feet. I know Flint Walling manufactures deep well jet pumps, and conservatively 90 feet you can pull water. You probably could even go as much as maybe 100 and 110 feet with some of our designs. But the deep well jet pump is going to be referred to as a two-pipe system. And so there's a visual difference in the characteristics of these two jet pumps, the shallow well jet pump and the deep well jet pump, that I hope to be able to show you here in a second. All right. I'm sorry, I have to move my dashboard. I only have one screen today, so I don't, I'm seeing what you see at the time you see it. So moving on then with these jet pumps, would not be uncommon for a contractor back in the day to go out to that hole that he dug, and down in that hole would not only be the jet pump that you see sitting here on a block, but there would be a pressure tank down in that well pit as well. So the entire water system, for the most part, is going to be located in this well pit area here. In the case of a shallow well jet pump, if that's going to be used, again, with the water table not being further than 25 feet, we will run a suction pipe right down into that well and put a foot valve on the bottom of it. Foot valve, very, very similar in design to a check valve, only allows water to go in one direction. A check valve will be used in line, typically in a line, and a foot valve will be at the end of a suction line. For all above ground pumps, typically they're going to have a foot valve at the end of that suction line. That foot valve has a screen on it, as you can see, kind of like the drive point we said in the earlier photo or slides, but that again is just to keep any large debris from being sucked up into the pump body itself. But that's what that foot valve looks like. Then on the top will be a well seal. Now, in a minute, we're going to go into submersible pumps, and that device that goes on the top of the well is referred to as a well cap. There's a big difference between a well seal, as you see pictured in the upper left corner, and a well cap. The well seal is designed, again, to protect that well so that we don't get encroachment from the outside, especially with any type of surface water. So in the case of a shallow well jet pump that only has one pipe, single pipe system going to the water source, that pipe will come down through this opening here in the top of the well seal. They'll put a pipe plug in that other opening, and then as you put that well seal in the casing and tighten these 4 bolts up, much like you would a tire, rotate around, it'll sandwich that and expand this rubber seal ring out against the inside walls of that casing, and that's referred to as a sanitary seal. And then from there, the contractor would he would dig a trench from the well pit into the house, and in that trench he would lay the water line and the electrical cables to run out there to that well pump. So oftentimes they'd bury that in the same trench, but that trench would be below frost level. So again, depending on where you're located in the country would depend on how far down you'd need to bury that water line so that it doesn't freeze in the wintertime. But this was a way that we were able to get water into a house, particularly up here in the northern part of the country, without anything freezing in the winter. There were some risks to the well pit, however, and they'd put a lid on the top of that thing, and sometimes they would put a heat lamp in there so that during the winter months they'd illuminate that heat lamp so that it would stay warm inside that well pit, and again to eliminate any possibility from freezing. But that's a typical installation of a jet pump in a well pit, and that device that's right here that I've got circled. Sometimes I get asked, why do they call a jet pump a jet pump? And I've had guys tell me, oh, I know why that is. And I ask them, well, what's your definition? They go, well, hell, have you ever heard one run? I'm thinking, no, that's not why they call a jet pump. You can't even hear a Flint Walling jet pump run. Everything in there is balanced. The reason they call a jet pump is that the pump itself is always going to be accompanied with a component referred to as a jet, this device here, or sometimes they'll refer to this as an ejector. But this, in the case of a shallow well jet pump, would either bolt right up to the front of the pump, as you can see here, or it would actually be a part of the pump casting. But nonetheless, this jet assembly is what creates the suction necessary for that pump to be able to pull water from that depth. And so that device right there, this jet, that's what creates that suction. If the water is deeper than 25 feet, as we talked about, now you can start getting into some choices. In today's world, a lot of guys are going to throw a submersible pump in that well. But, you know, back in the earlier days, submersibles hadn't even made their appearance yet. So we were stuck with deep well jet pumps. And as I mentioned earlier, a deep well jet pump is a two-pipe system. So in this case, you would have two pipes running down to the water source, which is the reason why there's two openings in the top of this well seal to accommodate both of those pipes if, in fact, this is going to be used on a deep well application. Now, I told you a minute or two ago that the reason they call a jet pump is because the pump must be accompanied by this component referred to as a jet or an ejector. And so in this case, the jet or the ejector on a deep well pump, this device that's designed to create suction, because the water is so far away from the pump, we need to put that device down closer to where that water source is at. And so therefore, you've got two pipes running down from the pump into this ejector or this jet. That's, in this case, it's going to be mounted vertically, and then just below that is going to be your drop pipe with the foot valve on it. But again, it's important to understand that static water level, because it's going to pretty much decide whether you can get away with using a shallow well jet pump or whether you're going to have to resort to a deep well jet pump. So those are the two types of jet pumps. Now, I'm going to switch gears here just a little bit. We've just bored the hole. We put the casing in. We've got water in the casing, and we talked about that as being the static level. We've sealed the outside of the casing. Hope I'm not moving this along too fast, but now we're going to switch. We're going to go to a drilled well. No well pit here anymore. This is more of today's type of technology. In fact, it's been this way for several decades. But we've got a drilled well here. We've got our casing set in the aquifer. We've got sealant around the outside of the casing, and we've got a static water level here. On the side of the well casing is a device referred to as a pitless adapter. That's this device here, or one that looks like it. So if you're going to install a submersible pump in today's world, and this has been the case for many decades, more than likely, you're going to have a pitless adapter that's going to go through the sidewall of that well casing. Now, if you look over where my cursor's at, there's two rubber seals here. One goes on the inside of the casing, one goes on the outside of the casing. And as you tighten this nut tight, that forms a watertight seal there around that hole that you've drilled in the side of that casing. That's what forms that watertight seal. And they'll set a submersible pump down in that well, and that submersible pump, that drop pipe, as you can see, will come right up into the bottom side of this pitless adapter, right there where I have my cursor. It'll come right there. And from there, we're going to take a water line into the house, and that's also going to be below frost level. Now, a lot of times when I get some newly hired people at Flint and Walling, I'm not sure what departments they may end up in, but one of the questions they ask me is, well, when that pump, you have that pump pumping water out the side of that casing through that pitless adapter. And I said, that is correct. Well, what stops that water from going right up straight through what stops it from just passing right straight through there? Well, it can't pass right straight through there because if you were to look, if you had this pitless adapter in your hand and you look down into the threads on the top side of it, it goes nowhere. It's blanked off. It's just there's nothing there. So that water can't go straight through. It has to go out the side. And so the question becomes, well, what's that all about then? You know, why do we have a threaded top to it? Well, in this particular design, what a contractor will do is he'll incorporate a handle. He'll take a piece of pipe, thread it into the top of the pitless adapter, maybe screw a T on the top side of it, and it becomes a handle. A handle for what? Well, if you ever have to pull that pump for any reason, you just lift up on it. You just pull up on that handle, and it will disengage from the other half of this pitless adapter. Now, that's why they call it a pitless adapter, because we just talked about a well pit. And now you're able to pull this pump out of a well. You don't have a big hole down there. You don't have pressure tanks located down there. You're able to pull that pump out of the well without disturbing any of the discharge piping running from the well to the house, to the pressure tank, so on and so forth. But it's almost, I think it's almost 100% of the time that a well drilled that's going to have a submersible pump in it, more than likely, if that well comes up out of the top of the ground, more than likely is going to have a pitless adapter in there. So there you can see how that pitless adapter kind of slides apart. This is just one design. There are many, many other designs out there for the same purpose. So this kind of just has a kind of a piece that just slides down into a slide rail here, and that O-ring on the inside, that's what seals it. This pitless adapter has a kind of a U-shaped band that goes around the outside of the casing. So as you tighten these bolts or nuts tight here, you're drawing that flange up against the casing and forming that watertight seal. In this case, instead of a handle, they've got a little piece of cable that you pull up, and it releases a lever on the back side, which frees this internal portion up so that you can pull the pump right up out of the well. And yet here's another one. Let me get this dashboard moved again. Here's another one here that as you rotate this handle, as you can see, it kicks this heel out and forces that O-ring up against the side of the casing. So you tighten it to seal it, and you loosen it to unseal it. But again, pitless adapters, there's a variety of different designs. I have no particular preference other than they all do achieve the same objective, which is the ability to pull that submersible pump up out of that well without disturbing any of the discharge piping. All right, moving on. Another accessory that is commonly used in the construction of a water system using a submersible pump is a component referred to as a torque arrestor. Now, again, this industry has a lot of variables. I mean, here where I'm located in Indiana, and you go over to Ohio, I mean, there's a lot of submersible pumps. In fact, probably most of them are installed in wells on polyethylene tubing that you can buy in either 100 or 300-foot rolls. I can remember that from back in the 70s even. So here where I come from, they hang submersible pumps a lot of times on, like I said, that polyethylene flexible tubing. Other parts of the country, they'll use rigid PVC of Schedule 80 or 120, and yet in other parts of the country, they'll hang them on steel, galvanized steel. A lot has to do with the weight and the horsepower of the motor, etc. But if you're hanging a pump and it's down in this well, 100 feet, and you're using that pliable coiled polyethylene tubing, I got news for you. That from the pitless adapter down to the pump, that tubing doesn't run straight. I mean, it's got a natural ability just to coil up, and so you'll get these bows in the line. There'll be subtle bows in the line. And so what a torque arrestor is designed to do is to keep everything centered inside that well. So we want to keep the pipe in the center. We want to keep the power line that runs down to the pump. We want to keep it in the center. We don't want any of that to be up rubbing against the side of that casing or even in making contact with the side of that casing, because every single time that submersible pump fires up, it's going to have a torque to it. And we all know that. It has torque. And so just like if you pop the hood of your car and rev that engine up, you'll see that engine want a torque too. And what we don't want is we don't want that pipe or any of that power line to be over near that well casing, where every time that pump fires up, it has a tendency to just kind of rub on that casing, because eventually and over time, you'll wear that through. And if it happens to be the power line, you're going to short the motor out. So anyway, these torque arrestors, there's a couple designs here, are designed to keep everything in the center. And so the way that they work is you can take these stainless steel clamps off this, and this opens up like a hot dog bun. You wrap it around the pipe, put a clamp on the bottom, go ahead and tighten that one up, and then push down on that rubber torque arrestor. And as you do, it increases in diameter. You want to get that thing out to where it's about the same as the inside diameter of your well, and then go ahead and tighten that top band up. That way, when you drop that down in the well, you've got a way of keeping that pipe in the center and that power line in the center. And sometimes, depending on the length of that well, they may have a couple of these in place or more. But again, its purpose is to keep the drop pipe centered, and your power lines that typically are going to run right down alongside of that drop pipe, to keep those also away from the outside walls of that well casing, or the inside walls of that well casing. There's another torque arrestor you see at the top right. This one here, I believe this has these tabs, these 4 tabs that you see. I have to go back and look again, but it's because it's been a long time. But I believe at one time they made those tabs so you could break pieces of those tabs off, and you could accommodate a variety of different size wells. So, you know, this might be designed for a 5-inch well. You break the tips off these tabs, now it can go in a 4-inch well, so on and so forth. That kind of a, but the way that torque arrestor would work is that these tabs would go out and they'd hit the inside walls of that well casing, and again, keeps everything in the center. So the center portion there would be where your drop pipe comes through, and then those little Mickey Mouse ears you see along the outside, that's where your power lines would come through. And again, it's not uncommon, depending on the depth of this well, that there may be more than 1 or 2 of these used in a water system. But either one is designed for the same objective, just like the pitless adapters were, and both are probably in common use to this day. So moving on. So we bring that water in from the side of the well through that pitless adapter. Now we're going to go into a pressurized storage tank. And that pressurized storage tank is going to be hooked up with a T. Oftentimes today's tanks are going to be, they got a single inlet, which also acts as the outlet. So you tee this onto the water line. These T's are referred to as tank T's. You see pictured at the top. The tank T's are available in either a long or a short configuration. Again, you've got a elbow typically welded in the bottom of this tank, and you got to get back in there and reach that elbow. And so a long tank T might be the one that you're going to use, so that it brings the T portion out beyond the skirt of that tank. If some manufacturers actually run that female thread right out to the edge of the skirt, and in that case, you don't need that long tank T. You can use the short, long or short. And then these tank T's, they're very popular because they hold a lot of other accessories that need to go along with a water system, such as a pressure switch here that I've got my cursor on. There's a pressure gauge located right here. This is a pressure release valve. Every pump manufacturer that I'm aware of always, and probably strongly always, recommends a pressure release valve so that it prevents overpressurization. Of course, over here is a hose bit. You know, if you want to be able to pull water off of that pressure tank, you can access it right here with a hose bit. Just behind us back here is an inline check valve. It acts like that foot valve. It only allows water to go in one direction. But again, when you look at this tank T, I think the reason it's so popular is because it's got a place for everything. You know, if you don't use a tank T, you still got to hook all this up somehow. And so that gets into making your own fabricated type of tank T, I suppose. I know some check valves had multiple tappings on them for the same type of purpose. But anyway, that's a tank T commonly used today because it can house and hold all the other components, such as that pressure switch. Now that pressure switch, again, we'll talk about that just for a minute. The typical traditional pressure switch used in the water systems industry is going to have a 20-pound differential. You can buy pressure switches that are factory preset for come on at 20 psi, off at 40, on at 30, off at 50, so on and so forth. Again, always a 20-pound differential. And if we look at that switch closely, Just to become a little more familiar with the switch itself, you've got your contacts or your terminals. Your terminals are back here, so the power coming in will come into the back of these on these terminal blocks, along with the power that you're going to run off to your pump. So those all hook in right here. There's where the contacts are. These are like a set of points that make and break, and that's what literally turns that pump on and off by virtue of supplying electric or not. You've got some grounding screws back in behind to properly ground this switch. And then you've got a couple of adjustments up front. Here's a tall, I refer to this as kind of a tall tower, spring-loaded, has a nut on it, all right? What that tower will do is it'll allow you to make your pressure adjustments up or down. So if you put a nut driver on that nut that I've got the arrow on, and you start to tighten that down, you're going to raise both the in or the cut in and the cut off pressure together. It's going to maintain that 20-pound differential, but you could literally take a 20-40 switch, put a nut driver on there, and start cranking that thing down. Watch the pressure gauge, because you can lift that now up that pressure to a 30-50, or you can keep going, and you go to 40-60. So even though they're factory set, you can always adjust that up and down pressure. And again, that adjusts both the cut in and the cut off. Now this smaller tower here, not quite as commonly used, but that smaller tower is going to be used to change that differential for whatever reason. It changes that 20 pounds. You can move it closer or spread it apart. Again, that's not a adjustment that I have found that's commonly used in the water systems industry. I suppose there are applications maybe that something like that would be beneficial, but by and large, most of the adjustments made on this pressure switch are going to be on the tall tower with that nut right there. And then on the very bottom is a diaphragm, and that diaphragm is what sees pressure. So as that pressure begins to build in the water line, it pushes up on that diaphragm, and when it does, it breaks these contacts. It literally separates them so that they're not providing electrical power to the pump anymore. And that's all controlled by that diaphragm on the bottom side there. All right, so any number of these accessories typically are used in a water system. I don't think I need to explain gauges or hose bibs or anything like that. So we're going to move right along off the tank keys now and look at how we power up this submersible pump. Well, first of all, let's go ahead and put our tank key on there with our switch and gauge. So we've got that in place. Then the next thing we'll do, and by the way, I'm going to walk through pressure tanks here very quickly. I want to try to pick up the pace. There's a sealed diaphragm. I'll circle back on that here in a little bit. But what we're essentially going to do is we're going to take power from the control panel to the pressure switch, and then that line that they trenched from the well into the house, probably going to put that power line in that same trench. But unlike the water line, it's not going to go through the side of the casing like the water line does. It goes right up to the edge of the casing, over the top and down. So that's what happens in a submersible pump. The water or the power line comes out to the casing over the top and down. They'll put a piece of conduit over that wire running up along the side of the casing so somebody doesn't hit it with a weed whacker or a mower. And then again, the cap that goes on the top. Unlike the sanitary seal that we saw with the jet pumps, this is referred to as a well cap. And you can see this little hump out here. That's to go ahead and accommodate that piece of conduit running up out of the ground up the side of that casing, a well cap. Now, this would be a typical wiring diagram, I suppose, for a 2-wire submersible pump. For those of you that are out west of the Mississippi, you sell a lot of 3-wire pumps out that direction. And so not a lot of difference here. We're going to bring the power into the switch and then up to a control box. And that control box will have a start relay and a capacitor in it. And then from that control box, now we'll go on out and do the same thing we just did previously with the 2-wire pump. But that's basically the wiring diagram there. If it's a jet pump, not much difference. So we're going to put this jet pump, but we're not going to have it in a well pit this time. But these jet pumps, sometimes today they're in basements, they're in crawl spaces. I got a father-in-law lives up in the eastern shore of Maryland. He's got a little pump house outside of his house where his pump sits. But a jet pump is going to install to the pressure tank exactly the same way. So we're going to hook it up to the pressure tank. It's going to have a tank key with the switching gauges on it. The power coming to power this jet pump. Oh, I'm sorry. Let me do that again. Yeah, that's a priming port. So a lot of times on jet pumps, you'll come out of the discharge, you'll incorporate a T, and then you'll put a plug in the top of that T so that this can become a priming port for initial and future opportunities where we may need to have to reprime this pump. But as far as the power goes, much the same way. We're going to come from the breaker to the switch and from the switch to the motor. That's typical shallow well pump there. And again, that shallow well is going to be used when the static water level is less than 25 feet away from an imaginary line that comes off that suction line. Now, I got to tell you, if you go back out to the website, I've got a web conference coming up. It's everything you want to know about jet pumps, and we'll peel the layers back on these things. There's a deep well jet pump, same thing, wires up the same way. You got two pipes running to the water source because your ejector or your jet's going to be closer to that water source. That's where that suction is going to need to be created down here in order for that pump to pump water. And that would be applications more than 25 feet. Looking at the clock, I'm down to about 20 minutes left here. So, all right. Sometimes I've been asked in my career, which is a few years now, what's a pressure tank do? You know, most all water systems today are going to have a pressure tank. I ask, what does it do? And I've got an opinion, and this is just my opinion. This is not a, I don't know that the industry blesses this answer or not, but if you ask me what it does, if you ask me what that pressure tank does, I'll tell you that it makes the whole system automatic. You see, there is a sealed diaphragm inside this pressure tank, all right? Sealed diaphragm. And if it's not a diaphragm, it'll be an air cell of some type of bag. But nonetheless, the objective in a captive air style tank that's typically sold today is to have a definite separation between the air that's in that tank and the water that will come into that tank. And that diaphragm has a lot of pliability to it, flexibility. It can move up and down. And so, again, if you ask me what this pressure tank does, in my opinion, it just makes the whole system automatic so that, yeah, every time you're using water, you don't need to turn the pump on, and you don't need to turn the pump off when you're done using water. Pressure tank will turn that pump on and off automatically as you use or choose not to use water. It'll control the pump, turn it on when it needs to, turn it off when it needs to. Well, how does that all work? Well, there's a rule of thumb, and the rule of thumb, with no water in this pressure tank at all, you just haul this thing out of your warehouse. It's in a pickup truck or truck, or you haul it out of the truck. There's no water in that tank at all. Not be a bad idea to put an air gauge on that little snifter valve that's on the top of that tank. Sometimes they're mounted right on the side of it, but irrespective, there'll be an air valve located on the top of this tank. Like I said, either on the side or on the top. And with that air valve, here's the rule of thumb. The air pressure in the tank with no water in it, right? With no water, just an empty tank. The air pressure in the tank needs to be 2 to 3 pounds below the cut-in pressure of the pressure switch. So we talked a few minutes ago that pressure switches can come in a variety of ranges, 20-40, 30-50, 40-60. So that's why it's not a bad idea to throw a tire gauge on there and just read what that air pressure is in that tank before you install it. Because if you have a 20-40 switch, you're going to want 17 to 18 pounds of air in this tank, right? 2 pounds below the cut-in pressure. If it's a 30-50 switch, 27 to 28 pounds, and so on and so forth. So this air charge in this tank with no water is 2 pounds below the cut-in pressure of the pressure switch. Now, I have to believe that though Flint & Walling does not manufacture tanks, we do have a supply of tanks that we have available. And I'm pretty sure, not 100%, I'm pretty sure they'll have about a 28-pound air charge in them, because the assumption is that most submersible pumps sold today are going to be sold at least with a 3050 switch. So if you're not using that 3050 switch and you're using a 2040 switch, you may want to take a little bit of air out of that tank to get it down closer to the 18 psi versus the 28. And again, if you're going with the 4060, you're going to have to add some air to it. But it's important to that air in that tank follow this rule of thumb, because that pressure gauge will start flip-flopping all over the place on you if it's not correct. So here's how they work. You got an empty tank, all right? Let's just assume, and this water line's coming from the pump or the water source, this line over here, and of course we're headed off to the house in the other direction, but let's just assume that this pressure switch here, it's going to operate a submersible pump, is going to be operating at a pressure range 30 to 50 psi. I just told you this a minute ago, so if that's the case, and it's a 30-pound pressure cut in, we need to have at least 2 pounds below that. So we're going to have a tank with about 28 pounds of air in it. That's it. All right? Pump starts for the very first time. Pump starts. Now it can't, as the pump's pumping water, it could flow right through that T, but it can't go anywhere because I got the valve closed over here, all right? So I'm just firing this pump up. So now what happens is, since the water can't travel straight through that closed valve, now the water is going to come in that T and start to fill a tank on the bottom side of that diaphragm. And that pump will keep on running, and it keeps putting water in there. Well, as it puts the water in that pressure tank, that water and that diaphragm begin to compress the air that's above it. We're at 38 pounds. Well, that switch is not going to shut off until it gets to 50, so the pump keeps on putting water in. And now we're getting really close to the point where that pump's going to shut off, because the air pressure's been compressed down to 48 psi, and we add a little bit more water to that, we get to 50 psi, and that pump shuts off. That pump shuts off. Why? Because that is all got 50 pounds of pressure in right here, all of it. And that line going up to that pressure switch, push that diaphragm up, it may disconnected those contacts, and that pump shut off. There's a check valve here that's going to stop any water from wanting to travel backwards. That only allows water to go one direction. If you don't have a check valve here, most submersible pumps have one right in the discharge. So this water is going to all be held, and so it maintains that 50 pounds of pressure. Now, we use water in the house, so I'm going to open that valve up. All right, I'm going to open that valve up, and now I create a demand in the house. I'm taking a shower, I'm running the dishwasher, I'm flushing toilets, whatever. Well, as soon as I open that faucet up in the house, what happens is all that air pressure that's on the top side of that diaphragm now pushes that water the other direction. And so as the faucet is running, that water that's coming out is actually coming out from being stored in that pressure tank. And it keeps pushing it out until it reaches that low pressure again. Boom, right there. Now the pump's going to come on, and we go through this cycle again. And that's why I say a pressure tank with the proper air charge in it is really what makes this system automatic, because it acts as that cushion so that the pump's not having to run every time you open a faucet. You've got water in that tank that's going to be delivered to you without having the need for the pump to come on. Then the pump will, once it gets to 30 psi, the pump will restart again. While the pump's running and you're using water, it's going to provide that water right past that tank to you, and it's going to supply water to meet your demand. If that pump is actually pumping more water than you're using, then the excess is going to go into this tank and begin to, like I said, begin to build up on the bottom side of that diaphragm again. So this amount of water that we put in these tanks, all right, from being empty until shut off, right? And from the time the pump starts until the time the pump stops, the amount of water stored in a pressure tank is referred to as drawdown, and oftentimes that's going to be measured in gallons. But a brief description of drawdown is the amount of water that tank will provide between pump cycles. Now, back in the day, and I don't know if my next slide shows this, but back in the day when I first started, uh, we sold a lot of galvanized steel tanks. And some of you that are a little more seasoned, perhaps, you know what I'm talking about, these galvanized steel tanks. The biggest, number one problem is that they would waterlog because you'd lose the air. The water itself would absorb the air over time, and you'd lose that cushion. And now all that was just a great big tank filled with water. If this diaphragm or the bag ever ruptures and you lose the air in one of these, you'll waterlog these tanks too. And the biggest single symptom is a rapid cycling of the pump, on, off, all the time. Rapid cycling, more than likely due to a waterlogged pressure tank. Now, down to my last slide or so, but this drawdown will vary. The amount of water that this tank will store is going to vary based on your pressure switch settings, i.e. the lower the pressure switch setting, the more the drawdown is going to be. When we look at, there's your old galvanized steel tank versus these captive air style tanks. This galvanized steel tank here, the drawdown, that thing was tall, man. That was 42 gallon. That held 42 gallons of water. And yeah, that thing was probably 4 or 5 feet tall, took a lot of space up. And on a 3050 switch, it'd give you 6 gallon of drawdown. Now you wonder why these tanks have been replaced over the time with these captive air style tanks. The answer to that is, first of all, the waterlogging situation is nowhere near as prevalent as it once was. And in the case of a 20 gallon captive air style tank, about half the size of that guy over there on the left, the drawdown was comparable. And so that's why these tanks are so popular today. But I mentioned a few minutes ago, you take these tanks here. This is just something comes out of our catalogs here. But I want to show you this. These are total tank volume. I come down here to 20 gallons. Right there's 20 gallons. Okay. These are my drawdown gallons by PSI settings. So in that 20 gallon tank, if I'm operating on a 2040 switch, I would expect to get 7.4 gallons of drawdown. On a 3050, 6.2, and we start to go up to the 4060. And as you can see, the higher the pressure, the less water that's going to be held as far as drawdown goes. I am rapidly approaching the top of the hour now. Again, this was just a fundamental discussion of some basic water systems, how the accessories are used, how the wiring's put in, how the pressure tank operates. So with that, I'm going to close this one off. One thing that we are currently working on is a way to make these courses a little more interactive. I know I had probably got 40 people on right now, and it's just tough to open the phone lines up with that many people. But if you've got a question or comment, if you got a question or clarification, you can email me directly at dpainter@flintandwalling.com, and I will respond back to you straight away. Folks, enjoyed being with you this afternoon. Be safe, and until next time, take care, and thank you very much. This web conference is now ended. Thank you.